Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 4 Vectors and Three-Dimensional Geometry. Topic Vectors. Subtopic Addition of vectors, multiplication of a vector by a scalar. Components of a vector. Position vector of a point dividing a line segment in a given ratio. Exercise 10.2. Addition of vectors. Let A and B be two vectors which are represented in magnitudes and directions by AB and BC. As in this picture, A vector bu AB na B vector bu BC na mahut silasi magnitude amasung maikay singda. Then their sum or addition A vector plus B vector is represented in magnitude and direction by AC line segment. A vector plus B vector asi AC asina magnitude amasung direction da mahut silani. Thus, AB vector plus BC vector equal to AC vector. Remark: for any vector A vector plus 0 vector equal to 0 vector plus A vector equal to A vector. Any vector A ga 0 vector ga adding tauba matamda always any vector tagane. The vector 0 is the additive identity for vector addition. 0 vector asibu vector tinjinabagi additive identity vector kawi. Parallelogram law of vector addition. If two vectors A and B are represented in magnitudes and directions by two adjacent sides of a parallelogram, then their sum A vector plus B vector is represented in magnitude and direction by the diagonal of the parallelogram through their common point. A vector amasung B vector ani sibu maikai singda amasung asang basing magnitude singda AB amasung AD haiba parallelogram amagi thangnaba side anina mahut silabade A plus B haiba vector anigi sum asi vector aniduga common point oiba starting oiba adugumba point adudagi singthorakpa diagonal aduna magnitude amasung direction da mahut singani masibo aikoina kari kawi parallelogram law of vector addition kawi. Prove that vector addition is commutative. That is, any two vectors A and B, A vector plus B vector is equal to B vector plus A vector. Solution. Let A vector is represented by AB vector and B vector is represented by BC directed line segment. Then, by definition of vector addition, A vector plus B vector will be represented in magnitude and direction by the AC. Complete parallelogram ABCD. ABCD haiba parallelogram asi mapung phahallo. Then, A vector asi originally directed line segment AB na mahu sunkhibani. Hojik AB vector asi bu DC directed line segment asi na mahu silani maramdi AB amasung DC side anisi parallel oi sangba manai. Loinena B vector asi hana na BC directed line segment asi na mahu singkhibani mahako amuk AD na mahu silani maramdi AD amasung BC line segment anisi parallelogram amagi opposite side anini parallel oi sangba manai. Therefore, B plus A is equal to B is equal to AD vector, A is equal to DC vector. By definition of vector addition, skip D, we get AC. B vector plus A vector so AC na mahu silli. Adubu AC vector asi AC directed line segment asi hana na A vector plus B vector bu mahu sinkrabani. Maram asidagi right anise manarabadi left anise manare haibadi A vector plus B vector equal to B vector plus A vector. Masibo aikoina kari kawi vector addition is commutative. Vector tinjinabasi ahan akongi makha ponde haba. Prove that For any three vectors A vector, B vector and C vector, A vector plus B vector plus C vector equal to A vector plus B vector plus C vector. Vector addition is associative हाइबने. Let A vector is represented by directed line segment AB and B vector is also represented by directed line segment BC, and C vector is also represented by directed line segment CD. Join A ga C ga samjinaro, B ga D ga samjinaro, A ga D ga samjinaro. Therefore, A vector plus B vector plus C vector, A vector is equal to AB vector plus B vector is equal to BC vector, and C vector is equal to CD vector. By definition of vector addition, AB plus BC is equal to AC vector. Again, AC vector plus CD vector is equal to AD vector. Right hand side to A vector plus B vector plus C vector equal to A vector is represented by AB and B vector is represented by BC, C vector is represented by CD. Sum of BC plus CD is equal to BD, and again applying vector addition, AB vector plus BD vector the AD vector right and is manarabadi left ani manare. Therefore, this equal to this. This shows that vector addition is associative. Multiplication of a vector by a scalar. Multiplication of a vector by a scalar. Vector amar scalar amana puriba. Let A be a given vector and lambda a scalar. Then the product of the vector A by the scalar lambda, denoted by lambda A, is called the multiplication of vector A by the scalar lambda. The vector lambda A has the direction same or opposite to that of vector A as the value of lambda is positive or negative. Also, the magnitude of lambda A vector is lambda times the magnitude of the vector A. Lambda A haibasi vector amani mahaki magnitude mahaki maikaidi A ga managani, lambda na positive oirabadi, lambda na negative oirabadi maikai opposite oigani. Magnitude lambda times the magnitude of the vector A. Lambda A have a vector C gi magnitude lambda times the magnitude of vector A. Vector A gi magnitude ka lambda ga ani gi purina baduna lambda A vector gi magnitude oigani. As in this picture sida this is a vector ni. A vector sida k have a positive number amana purirabadi k a vector ni. A vector ga k a vector siga ani simaikai or magnitude kene. Aduga k have a negative oirabadi k a have a new vector asigi maikai se a vector sigi opposite direction the sakene. Components of a vector. The position vector of a point P whose coordinates are x, y, z with reference to origin O is OP vector. As in this picture, P have a point number space the coordinates in x, y, z. Asang basina x axis, nisina y axis, up and down sina z axis. Generally, x axis ke positive direction the satpa unit vector wo I cap lowi positive direction of z y axis the satpa asibuna unit vector buna z cap aduga positive direction of z axis the satpa unit vector buna k lowi. Hojik P hariba point asidagi xy plane asida perpendicular drop torasi PM hariba M is the foot of the perpendicular. M hariba point asidagi amuk x axis the perpendicular ama M L hariba ama drop toroksi. Mathakta P gi lawkiba coordinates into x y z harabanina O dagi L ba ka sangba si x ni, L dagi na M ba ka sangba sina y ni, M dagi na P ba ki awang ba sina z ni haba si koi khangle. OP vector haba se sum of three vectors. OP vector haba si OM vector plus MP vector ni amuksu OM vector si ON vector LM vector ni. From this figure we know that OP vector is position vector of the point P with O as origin, and OL vector plus LM vector plus MP vector. OL is equal to OL gi magnitude OL na khangna rani I cap na puri rani vector C hojik asumna rewrite tokpa yai lm haibasisu lm gi magnitude lm denotes lm and L dagi M the L dagi M the chatpa unit vector is j cap lerani plus mp vector mp mp lere p m dagi p ro chatpa unit vector is k cap ni ol habasi point p gi x coordinate na sindokharani lm habasi na y na sindokharani mp habasi na z na sindokharani thus OP vector is what x times of I cap plus y times of j cap plus z times of k cap space ta leba point amagi origin of the coordinate system aduna origin oina treat tauba point adugi position vector de point adugi coordinate singda I j k na mathang sina puriraga sum up taugani. Here x, y and z are called the scalar components of OP vector. Mafam asida is number x, y amasung z haibasi OP hariba vector asigi scalar components in kawi and x times of I cap, y times of j cap and z times of k cap are called the component vectors of OP vector along the respective axes. Hariba vector ahum asina component vectors kawi OP hariba vectors sing asigi x axis, y axis, z axis tamatang sina. Also, magnitude of OP is magnitude of xi plus yj plus zk cap and which is equal to square root of x square plus y square plus z square. OP hariba line segment asigi asangba sidi point p gi coordinate sing adugi square singi sum gi square root na pirani positive square root na pirani. Some properties of component vectors. Component vectors singi property kara. Let a vector equal to a1 I cap plus a2 j cap plus a3 k cap and b vector equal to b1 I cap plus b2 j cap plus b3 k cap. Then ahanbada a vector plus b vector. Components in the pongokpa vector singi sum de we get a1 plus a b1 times of I cap plus a2 plus b3 times of j cap plus a3 plus b3 times of k cap. Asumna component of pongokpa vector singi sum the I gi coefficient singi sum times of I cap plus b j gi coefficient j gi vector singi scalar component singi sum asumna mathang sina lakani. Khaidoknaba matamdadi a1 minus a b1 times of I cap plus a2 minus b2 times of j cap plus a3 minus b3 times of k cap. Vector component of pongokpa vector ani manarabadi corresponding components in managani haibadi a1 equal to b1 a2 equal to b2 a3 equal to b3 ahumji chungmani. Scalar amana adugumba component of pongokpa vector amagi scalar multiples the scalar duna component khudingmakta purigani haibadi lambda a1 times of I cap plus lambda a2 times of j cap plus lambda a3 times of k cap. K times of a vector plus m times of a vector have a vector se common log vi k plus m times of a vector. Sumna k times of m a vector di k m times of a vector hani itokvi. K times of a vector plus b vector di k times of a vector plus k times of b vector. Number 8. If a vector is expressed in component ijk and b vector is also expressed in components ijk are collinear, then a vector equal to lambda times of b vector. Lambda is a non-zero number. Vector component of pongokpa vector ani parallel collinear oirabadi. Collinear means parallel oirabadi vector amana amagi scalar multiple soigani. A vector equal to lambda times of b vector or b vector equal to lambda times of a vector. Mafam asida sisinariba lambda si zero dinate. Zero nataba any real number. Also assume b1 by a1 equal to b2 by a2 equal to b3 by a3 equal to lambda. Assume the component sing the pongokpa vector ani collinear oirabadi makoi gi component sing the proportional oigani. If a vector equal to a1 I cap plus a2 j cap plus a3 k cap, then a1, a2, a3 are called directional ratios of a vector. Component of pongokpa vector amagi scalar component singasi vector adugi directional ratios kawi. If a cap equal to L times of I cap plus m times of j cap plus n times of k cap is a unit vector along a vector, then L, M, N are called direction cosines of a vector. Karigumba unit vector ama components in the I j k da phongdoklabadi karigumba unit vector ama I cap j cap k cap by the component ahum da phongdoklabadi makhoigi scalar components in L M N C vector adugi direction cosines. Section formula. The position vector of the point R which divides the line segment joining the points P and Q whose position vectors A vector and B vector internally in the ratio m is to n is mb vector plus na vector by m plus n. P amasung Q position vector singna A amasung B oiba mabani samjinaba lai makak adubu manungda m is to n da khaidopa point R haiba amagi position vector si m times of b vector plus n times of a vector by m plus n oigani. Let us prove. Let P and Q be the 2 points represented by the position vectors OP and OQ with O as origin S in this picture. P amasung Q haibasi a vector amasung b vector na position vector or on origin oiba point singni. Let R be a point which divides the line segment joining P and the Q internally in m is to n. R haiba point sina PQ samjanaba lai makaksibu m is to n da khaidokle. Let A vector, B vector and R vector be the position vectors of P, Q and R with O as origin. Hariba P vector A vector na point P ki position vector ni, B vector na point Q ki position vector ni, aduga R vector sina R hariba point C ki position vector ni O na origin on lauraga. Let's see. Since m is to n habadi P dagina R ki asangba is to R dagina Q ki asangba. Ratio the labor masingani manarabadi by properties of ratio and proportions we get product of extremes equal to product of means matai gi ani purina baga mayai gi ani purina baga manai loinena r dagi q satpa mai kai siga p dagi r satpa mai kai manarabani madu simultaneously koina vector da su onthok lame P the R dagi Q the satpa vector amagi karamna phongdokani makhoi gi n point singi position vector Q gi position vector B dagi minus R gi position vector R na khaidokani asumna P dagi R the satpa point amagi position vector se R gi position vector R dagi minus P gi position vector a khaidokhigani hojik scalar sinamanungo loina purina ro aduga R yawba vector ani du left transfer taro aduga R kama lokhokro hojik R putokshi mb vector plus na vector m plus n yele. Hence, position vector of the point R which divides P and Q internally in the ratio of m is to n is OR vector which is equal to mb vector plus na vector by m plus n. The position vector of the point R which divides the line segment joining the points P and Q whose position vectors A vector and B vector externally in the ratio m is to n is mb vector minus na vector by m minus n. R haiba point amana PQ samjinaba position vector singna AB oiba mathang sitna mapanda m is to n da khaidokpa point amagi position vector da mb vector minus na vector by m minus n oigani haibani hariba picturization adudi p dagi q rom da p dagi q rom da r haiba point ama lawro natragana q dagi p rom da sangdo su point r sidi pq samjana laigi q thongba side natraga p thongba side thongani exponent division oirabani na hanagi formula adu da plus kudunga minus na change taraga phangmani. The position vector of the midpoint of the points P and Q whose position vectors A vector and B vector is A vector plus B vector by 2. P amasung Q position vector na A vector amasung B vector oiba lai makak asigi mayai bindu gi position vector di vector anidugi sum da 2 na yelaga phangani. Vector joining 2 points point ani samjinaba lai gi point ani samjinaba vectors. Let P whose coordinates are x1, y1, z1 and q x2, y2, z2 are to any 2 points, then PQ can be equal to x2 minus x1 times of ik plus y2 minus y1 times of jk plus z2 minus z1 times of kk, and the magnitude of PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Exercise 10.2. Question number 1. Compute the magnitude of the following vectors. Makhada piriba vectors sing asigi magnitude sing putu ahanba wahang. Magnitude of A is denoted by a vector the single bar taken by a bounded organi, which is equal to square root of I coefficient 1 square plus j coefficient 1 square plus k coefficient 1 square, which is square root of 3 phange. Assume the B magnitude sing positive square root of I coefficient 2 square plus j coefficient minus 7 square plus k coefficient minus 3 square, which gives the square root of 62. Assume the magnitude of C is positive square root of I coefficient 1 by root 3 square plus j coefficient 1 by root 3 square plus k coefficient minus 1 by root 3 square, which gives 1. Assume the question number 1 write two different vectors having same magnitude. Magnitude manaba manadaba vector ani. Magnitude manaraga manadaba vector haradi vector ani do direction manararoi. Let a vector equal to ik plus twice jk plus 3k cap and b vector equal to 3ik plus 2jk plus k cap. Vector ani si magnitude manai maram square root of 1 square plus 2 square plus 3 square habasi square root of 14. Sig magnitude square root of 3 square plus 2 square plus 1 square so must is square root of 14. Vector and isi magnitude manai vector and isi maikai same different directions ne maikai manade. Similarly, for question number 3, write two different vectors having same direction. Maikai manaba vector manadaba vector ani haibani. Maikai manaba haragad maikai manaraga manadaba vector haragadi magnitude kenabatare. Let a vector equal to I plus ik plus j cap and b vector equal to a vector the 2 no purida twice I plus twice j 3 no purida ci. Hojik vector ani se scalar maikai manaba haragadi ahanba vector a asida positive number amana puriraga phoma vector na b koksingadabani. Adu orebdi vector ani se maikai manarani magnitude manararoi. For question number 4, find the value of x and y so that the vector these are equal. Vector and ise manarabadi x and y ki value putu haibani. Here these two vectors are equal, it is given. Then corresponding component of phongdokpa vector and manage harabadi corresponding parts ingo managadavani. I ki coefficient 2 songe I ki coefficient x ka manarane, that gives x equal to 2 and j ki coefficient 3 ga j ki coefficient y ka manarane, that gives y equal to 3. X की वैल्यू 2 और y की वैल्यू 3 और Question number 5. Find the scalar and a vector components of the vector with initial point to 1 and terminal point minus 5, 7. Point anisidagi point anisigi vector dugi scalar amasu vector components into putu ahan bawahang. Let A denotes to 1 and B denotes minus 5, 7. Therefore, AB vector D minus 5 to 2 kaidokra I cap plus 7 to 1 kaidokra j cap. That gives minus 7I plus 6j. Therefore, scalar components of AB vector are I coefficient minus 7 and 6 and the vector components of AB are minus 7I cap and 6j cap. Question number 6. Find the sum of these three vectors. Vector ohmsigi sum putuwaibani. We have vector ohmsigi sum the A vector plus B vector plus C vector ni A ki value pishalo, B ki value pishalo, C ki value pishalo. I ki coefficient I yaw tamsing punjalo, I yaw tamsing punjalo, J yaw tamsing amu punjalo, K yaw tamsing amu punjalo. Simplify to we get minus 4J minus K pangi. Machine vector ohmsigi sum ni. Matang question number 7. Find the unit vector in the direction of vector A. A vector sigma is chat per unit vector putu haibani. Here A vector is this. Mark in magnitude putoxi root over 6 pange. Therefore, unit vector along A vector. A vector ki is chat per unit vector A cap na khangnai. Which is equal to A vector divided by its magnitude. Masi formula in the simple pugadobani. Kariguma vector amagi is chat per unit vector putoke harabadi vector adumakta the mark in magnitude na yengadabani. A vector shidala area mark in magnitude 6 lare, which is the required unit vector along the given vector A. Number 8. Find the unit vector in the direction of vector PQ where P and Q are the points 1, 2, 3 and 4, 5, 6. Point anisi P dagi Q sapa vector asigi unit vector asigi unit vector puto. Here P is this, Q is this. Therefore PQ vector the x2 minus x1 times of ik plus y2 minus y1 times of jk plus z2 minus z1 times of kk can simplify to this magnitude putoxi PQ vector the square root of 3 square plus t square plus t square, that is 3 root 3. Therefore unit vector along PQ vector is PQ vector divided by its magnitude, which is equal to 1 by 3 root over 3 times of this 3 the 1 by root 3 times of ik plus jk plus kk. For question number 9, for given vectors a vector equal to this, b vector equal to this, find the unit vector in the direction of the vector a plus b. Ahanbada a plus b hana putoksi a plus b putoani I yaw tamani se combine to the I phange plus j yaw tamani se kakana kare k yaw tamani se sum up to the plus k phange. Therefore sigma mahaki magnitude to root over of 1 square plus 1 square, that is square root of 2. Therefore unit vector along a vector plus b vector is a vector plus b vector by its magnitude, which is equal to 1 by root 2 times of ik plus kk. For question number 10, find a vector in the direction of the vector this which has magnitude 8 units. Piramiba vector sigi maikaida magnitude 8 oiba Piramiba vector sigi maikaida leiba vector ama magnitude 8 oiba vector ama putu haibani. Let a equal to this. Apiba vector si a na khangna si maake magnitude log to si root over 30 lere. Therefore, required vector of magnitude 8 unit is I times of a cap. Maramdi a vector sigi magnitude unit vector 8 na puriraga magnitude 8 over vector si magnitude vector phangani. A cap is what a vector by its magnitude. Adu di maha ki value respective value a against the layer a magnitude is the layer. We get this, which is the vector of magnitude 8 in the direction of the given vector. Question number 11. So that the vectors are collinear vector and is collinear or haivani. Let a vector denotes the given first vector and b vector denotes the second vector. Then therefore b vector is b vector the common factor minus 2 we get this bracketed expression is replaced by a. Therefore b vector is scalar multiples of a vector. B vector is scalar multiples minus 2 times of a vector. Adu the vector a amasung b se collinear vectors ni. Minus 2 or a vector a vector b opposite direction or magnitude t a b vector की magnitude t a vector की magnitude t 2 times or. This shows that a vector and b vector are collinear or. Question number 12. Find a direction cosines of the vector this. Vector c की direction cosine putuaivani. Let a denote a vector denotes the given vector. Magnitude putoxi, then its magnitude is square root of 14. Therefore, unit vector along a vector is a cap and which is equal to a vector divided by its magnitude and which is again equal to this. Therefore, direction cosines of a vector are I coefficient 1 by root over 14, j coefficient 2 by root over 14, k coefficient 3 by root over 14. These are the direction cosines of the given vector A. Question number 13. Find the direction cosines of the vector joining the points A and B. Directed from A to B. A, B vector adugi direction cosines puto haivani. Here we have to find out A, B. x2 minus x1 times of ik plus y2 minus y1 times of jk plus z2 minus z1 times of kk, which gives this. Mahaki magnitude of unit vector puto ke hairabadi magi magnitude su puto mas we get 6. Therefore, unit vector along AB vector is AB vector की magnitude at by unit vector the vector sum of the magi magnitude 6 na yelani. Therefore, direction cosines of AB vector I are I coefficient minus 2 by 6, that is minus 1 by 3. J coefficient, that is minus 4 by 6, that is minus 2 by 3. K coefficient is 4 by 6, that is 2 by 3. Question number 14. So that the vector ik plus jk plus kk is equally inclined to the axis ox, oy, oz. Pyramid vector is the positive direction of the axis that equally inclined to haivani. Let A denotes ik plus jk plus kk. Then its magnitude is this root over 3. Therefore, the unit vector along a vector is a cap, which is equal to a vector by its magnitude, which is again equal to this. Therefore, the direction cosines of a vector are I coefficient 1 by root 3, j coefficient 1 by root 3, k coefficient 1 by root 3. Hence, the vector A is equally inclined to the axis of x or y or z. Haibadi vector A asigi direction cosine value sing loina manarabanina a vector sina positive direction of x axis, y axis, z axis equally inclined to have ule. Question number 15. Find the position vector of a point R which divides the line segment joining two points P and Q whose position vectors are this and this respectively in the ratio 2:1 internally and externally. Point P ga Q ga position vector sing piramlaba point ani sibu 2:1 da manungda amasung mapanda khaidokpa point adugi position vector putu haibani. Ahanbada the position vector of the point R internally divided over 2:1 da 2:1 divided over 2 ga anisu vector se puni plus 1 ga ahan vector se punani 2 plus 1 divided over we get this. For external division, the position vector of the point R to the Hazuki formula matak maya the plus to minus sindokre simplified to Question number 16. Find the position vector of the midpoint of the vector joining the point this and this. Point anisi samjinaba lai adugi mayai bindugi position vector putu u haven. Let a vector and b vector be the position vectors of the point P and Q. Then a vector is equal to 2, 3, 4 the ij kena puriro asumna b vector so 4, 1 minus 2 the ij kena mathang chena puriro. Therefore, position vector of the midpoint is a vector plus b vector by 2 no p. Babani sum up to we get this 2 no divide of token we get this, which is the required position vector. For question number 17. So that the points A, B, and C with position vector A equal to this, B equal to this, and C equal to this respectively form the vertices of a right angle triangle. Point ahumgi A, B, C haiba point ahum sigi position vector sing piramle. Point ahum sina right angle triangle amagi vertex oigani utlu haibani. We have AB vector puthokani B vector ki position vector minus A ki position vector khadakoni we get this. Assume B C की position vector देगी B की position vector खाजोकोने we get this. A C की position vector देगी A की position vector खाजोकोने we get this. Therefore, भारी बस sizing असी magnitude सिंग लोने लोग तो असी we get this. Now, A B vector की magnitude square plus A C vector की magnitude square अपिक पर नंबर नहीं की square सिंग sum पुतो असी we get 41. 41 the square root of 41 की square ni square root of 41 the magnitude of B C square का माना रे. This shows that ABC forms a right angle triangle. Point ahum sina right angle triangle amasemi haibo utle. Question number 18. In the triangle ABC, figure 10.19 is in this picture. Which of the following is not true? AB vector plus BC vector plus CA vector equal to 0 vector. AB vector plus BC vector minus AC vector equal to 0 vector. Haibadi triangle asida which is not true karambana chumba karambana lanbage hangmani piribasida sigi diagram sigi matungina di AB vector plus BC vector equal to AC vector ni AC duna right thanga abadi minus AC orani minus AC AB vector aduradi karambana sig chumme aduga siga su 1 A ga B ga so manai AB plus BC CA CD lale adudi lanba haragadi C lale Sidadi amo A B ga B C ga manare C A summe adudi C S lale. Question number 19. If a vector and B vector are two collinear vectors, then which of the following are incorrect? A ga B ga parallel of a vector single makage singas the karamba lan bage. B vector equal to lambda times of A vector for some scalar lambda. Sidi chumme. A vector equal to plus minus B vector sidi lale. The respective components of A vector and B vector are not proportional. Mabani proportional oidi haven. Mabani proportional oidi. Mabani ki mapa chanabda leba components into proportional oidi haven lali. Both the vectors A and B have same direction. Mabani muk same direction lay haven. Same direction lay but different magnitudes masisu lali. Karambana are incorrect haven. B C D B ne C ne D ne makoisingse incorrect ngakani absolutely chumbadudi A ni. Extra questions. Haribo questions singa si syllabus within syllabus to leba khotpa yaba ang question. Thank you for watching video.